Welcome. Tonight, we're going to journey together through the most peaceful corners of the cosmos, exploring facts about our universe that are designed not to excite or startle, but to soothe and calm. Picture yourself floating gently in the darkness of space, weightless and serene, as we explore the gentle rhythms and patient movements of everything around us. Before we begin our cosmic journey, I want you to get comfortable. Adjust your pillow, pull up your blanket, and let your body sink into whatever surface you're resting on. Take a deep breath in through your nose, hold it for just a moment, and then release it slowly through your mouth. Do this one more time. Feel your shoulders drop, your jaw relax, your eyelids grow heavy. The universe we're about to explore together is vast beyond comprehension, ancient beyond measure, and yet surprisingly gentle in its grand movements. Nothing in space happens quickly by human standards. Stars burn for billions of years. Galaxies drift for eons. Light travels steadily, patiently across immeasurable distances. There's something profoundly calming about these cosmic timescales, something that makes our daily worries seem incredibly small and temporary. Tonight, as you listen, you don't need to remember facts or test yourself on details. You don't need to stay alert or focused. In fact, the opposite is true. Let yourself drift. Let your mind wander among the stars. If you fall asleep before the end, that's absolutely perfect. That's exactly what this journey is designed for. The universe will still be here tomorrow, vast and patient, waiting to share its quiet secrets whenever you're ready to listen again. So close your eyes if you haven't already. Take another slow breath, and let's begin our gentle exploration of the most relaxing facts about the universe. The vastness and emptiness of space. One of the most comforting truths about our universe is just how much empty space there is. When you look up at the night sky, it might seem crowded with stars, but this is merely an illusion created by our vantage point and the limitations of human vision. The reality is far more spacious, far more peaceful. Consider this: the average distance between stars in our galaxy is about 4 light years. A light year is the distance light travels in 1 year, moving at roughly 300,000 kilometers every single second. That's a distance so vast that it would take conventional spacecraft thousands and thousands of years to traverse. And that's just the distance between neighboring stars, the closest ones to each other in our cosmic neighborhood. To put this in perspective that might help you visualize it more clearly, imagine if our sun were the size of a basketball. On this scale, the nearest star to our sun, Proxima Centauri, would be another basketball located about 6,500 kilometers away. That's roughly the distance between Istanbul and New York City. Picture that vast expanse of ocean, land, and sky between those two cities, and imagine it all being completely empty space, containing nothing but the gentle drift of atoms, the whisper-quiet passage of cosmic radiation. Between stars, between galaxies, between all the bright points of light we can see, there stretches an incomprehensible emptiness. This isn't a cold, frightening void. Rather, it's a peaceful expanse, a cosmic ocean of tranquility where nothing disturbs the silence. No air carries sound. No particles collide with any frequency. It's the deepest, most complete silence imaginable. Our Milky Way galaxy, which contains somewhere between 200 billion and 400 billion stars, stretches about 100,000 light-years from edge to edge. Within this enormous disk, stars are scattered like grains of sand on an impossibly vast beach, each one separated from its neighbors by distances that dwarf anything we experience in our daily lives. The Sun, our local star, orbits the galactic center at a sedate pace of about 800,000 kilometers per hour, which sounds fast until you realize that at this speed, it still takes roughly 230 million years to complete a single orbit around the galaxy. We're traveling through space right now, spinning on Earth, orbiting the Sun, all while the Sun itself glides through the galaxy, and yet everything feels perfectly still. Between galaxies, the distances become even more profound, even more peacefully vast. Our nearest large galactic neighbor, Andromeda, lies about 2.5 million light-years away. The light you see from Andromeda when you look up on a dark night left that galaxy 2.5 million years ago, long before humans existed on Earth. Between our Milky Way and Andromeda stretches an enormity of space that contains very little at all, just the occasional stray star or cloud of gas drifting in the galactic emptiness. Scientists estimate there are roughly 2 trillion galaxies in the observable universe, each one separated from its neighbors by millions of light-years on average. Imagine if each galaxy were a grain of sand, and then imagine these grains of sand scattered across an area larger than the entire Earth's surface. That's roughly the distribution we're talking about. Vast expanses of peaceful nothingness punctuated by islands of light and matter. This emptiness serves a purpose in creating the calm stability of our universe. With so much space between objects, collisions are incredibly rare. Stars almost never run into each other, even when entire galaxies pass through one another, because the distances between individual stars are so enormous that they simply glide past like 2 clouds of fireflies interpenetrating without any individual firefly ever coming close to another. Planets orbit their stars in peaceful, predictable paths through empty space, disturbed by nothing, influenced by nothing except the gentle, steady pull of gravity. In this vast cosmic ocean, even traveling at the speed of light, you could journey for years without encountering a single atom of matter. The space between stars is so empty that if you could scoop up a cubic meter of it, you'd find it contains fewer than 1 atom on average. Compare this to the air you're breathing right now, which contains trillions upon trillions of molecules in that same cubic meter. The vacuum of space is a purity of emptiness that nothing on Earth can match. This profound emptiness creates a universe that is, paradoxically, incredibly stable and peaceful. With so much room between objects, there's no crowding, no jostling, no competition for space. Everything has room to exist, to move, to follow its own path through the cosmic darkness. The universe is patient and spacious, offering endless room for stars to shine, for planets to orbit, for light to travel unimpeded across billions of years. When you feel crowded in your life, when the world seems too full of noise and demands, remember this cosmic emptiness. Remember that you're made of atoms that were once scattered through that peaceful void, that you're built from stardust that drifted for eons through silent space before gathering together to form planets and eventually living things. In your very substance, you carry the memory of that cosmic peace, that fundamental spaciousness of existence. The universe gives everything room to breathe, room to exist without pressure. In the grand scheme of things, there's space for everything, time for everything, and no rush whatsoever. This is one of the universe's most comforting truths. There's always more room, always more time, always more peace to be found in the vast, gentle emptiness between the stars, cosmic timescales, and universal patience. If the emptiness of space teaches us about cosmic serenity through distance, then the timescales of the universe teach us about peace through duration. Nothing in the cosmos happens quickly. Everything unfolds with a patience that makes human lifetimes seem like the blink of an eye. Our sun, that brilliant yellow star that warms our planet and makes life possible, has been burning steadily for about 4.6 billion years. Think about that number for a moment. 4.6 billion years. If you tried to count to 4.6 billion, even counting one number every second without stopping to sleep or eat, it would take you over 145 years. And that's just to count the years the sun has existed, not to experience them. The sun will continue burning for approximately another 5 billion years before it begins to run out of hydrogen fuel. This means that, from beginning to end, our star's main sequence lifetime spans roughly 10 billion years of steady, reliable fusion. Every single day for billions upon billions of days, the sun rises and sets, burns and shines, fusing 600 million tons of hydrogen into helium every second. And yet this process depletes its fuel so slowly that billions of years pass without any noticeable change. This is the cosmic tempo, the universe's preferred pace. Slow, steady, imperceptible on human timescales, but ultimately transformative given enough time. Stars don't flicker into existence and wink out moments later. They form gradually from collapsing clouds of gas over the course of millions of years, shine steadily for billions of years, and then die in processes that themselves can span millions more years. When a star like our sun finally does run out of hydrogen in its core, its transformation into a red giant doesn't happen overnight. The star gradually swells over millions of years, gently expanding its outer layers until it's enormous enough to engulf the inner planets of its solar system. Even this death is drawn out, peaceful in its slowness, giving any observers billions of years of advance warning. Eventually, the red giant sheds its outer layers in a process that takes hundreds of thousands of years, leaving behind a white dwarf that will cool so slowly that the universe may end before it finishes fading. More massive stars have shorter lives, but even short in cosmic terms means millions of years. A star 10 times the mass of our sun might burn through its fuel in just 20 million years. This is considered fast in cosmic terms, yet it's still longer than the entire existence of our human species. Even the most dramatic events in these massive stars' lives, the supernova explosions that mark their deaths, are preceded by thousands of years of preparation as the star builds up layers of different elements in its core. Galaxies themselves evolve even more slowly than individual stars. Our Milky Way galaxy has been around for approximately 13.5 billion years, formed from the condensation of primordial gas in the early universe. Over this vast span of time, it has maintained its basic spiral structure, slowly gathering more material, forming new stars, watching old stars die, all while maintaining a stable, recognizable form. When galaxies collide, as they occasionally do in the fullness of cosmic time, the interaction plays out over hundreds of millions of years. The Milky Way and Andromeda, those two great spiral galaxies, are moving toward each other right now, slowly drawn together by their mutual gravitational attraction. They're approaching at about 110 kilometers per second, which sounds rapid, but given the distance between them, they won't actually begin to merge for another 4.5 billion years. Their collision, when it does happen, will be a slow-motion dance spanning 1 billion years, with the two galaxies passing through each other, interacting, separating, and eventually merging into a single elliptical galaxy. But here's the beautiful part. Even during this galactic collision, individual stars will rarely, if ever, come close to each other. Remember that vast emptiness we talked about earlier. Even as two galaxies interpenetrate, the spaces between stars are so enormous that collisions between individual stars are essentially impossible. From the perspective of a planet orbiting a star in one of these colliding galaxies, the main visible change would be a gradually shifting star pattern over millions of years, eventually revealing more and more stars from the approaching galaxy scattered among the familiar constellations. It would be a slow, gentle transformation, not a violent collision. These cosmic timescales put everything in perspective. If you're worried about something happening tomorrow or next week or next year, remember that the universe measures time in millions and billions of years. To the cosmos, your worry is less than an instant, a moment so brief it's essentially indistinguishable from zero. This isn't to diminish your concerns, but rather to provide perspective. The universe teaches us that almost nothing is truly urgent. Time flows in such abundance that there's always enough of it for everything that needs to happen. The rocks beneath your feet, if they could speak, would tell you stories spanning hundreds of millions of years. The atoms in your body have existed for billions of years, cycling through generations of stars, scattered through space, gathered into planets, incorporated into living things, released again, and finally ending up as part of you. Each atom in your body is ancient beyond comprehension, and will continue to exist long after your lifetime ends, patient and eternal, moving through the universe at its own unhurried pace. Mountains rise and erode over hundreds of millions of years. Continents drift across the face of the earth at the pace of fingernail growth. Oceans open and close across tens of millions of years. Even these earth processes, which seem eternal to us, are rapid flickering compared to the stately evolution of galaxies and the patient burning of stars. The cosmic microwave background radiation that fills all of space is light that has been traveling for 13.8 billion years, since just 400,000 years after the Big Bang. This light has been journeying through space for almost the entire age of the universe, crossing distances so vast that billions of years were required to traverse them. And it will continue traveling, growing ever more redshifted, ever more dilute, but never stopping, never hurrying, just maintaining its patient journey through the expanding cosmos. Black holes, those enigmatic objects from which not even light can escape, evaporate through a process called Hawking radiation. But this process is so incredibly slow that even the smallest black holes would take billions upon billions of years to completely evaporate. Black holes with the mass of stars would take far longer than the current age of the universe to evaporate. Some physicists calculate that the largest black holes might take 10 to the power of 100 years to evaporate, a time span so immense that all the stars in the universe will have long since burned out, leaving the cosmos dark and empty except for these slowly evaporating giants. This is the message the universe offers us. Patience. Everything happens, but in its own time. Stars form and die. Galaxies collide and merge. Elements are created and scattered and gathered again. But none of this is rushed. None of it is frantic. The cosmos operates on timescales so vast that urgency becomes meaningless. From the perspective of the universe, there's time for everything. There's no need to rush, No need to panic. No need to worry that time will run out before things can unfold as they need to. As you lie here tonight, breathing slowly, feeling your body relax, remember that you are suspended in this ocean of cosmic time. Billions of years preceded your existence. Billions more will follow it. You are part of this vast, patient unfolding of the universe, this slow dance of matter and energy across the ages. There's no rush. There's nowhere you need to be except exactly where you are. Time, that commodity that feels so scarce in daily life, exists in such abundance in the universe that its vastness can barely be comprehended. Let yourself feel small in a good way, held within this immensity of time. Your worries, your stresses, your anxieties, all the things that feel so pressing right now, all of these will pass. Everything passes, given enough time. And the universe has more time than you could ever need. Rest in that knowledge. Let the patient, unhurried nature of cosmic time soothe your racing thoughts. The universe is in no rush, and neither, for tonight at least, are you. The building blocks. We are made of stars. There's a beautiful truth about your physical existence that connects you intimately to the cosmos. Every atom in your body, except for hydrogen, was created in the nuclear furnace of a star. You are literally made of stardust, assembled from the ashes of ancient suns that lived and died billions of years before our solar system even existed. Let me explain how this works, because understanding our stellar origins is one of the most comforting connections we can feel to the universe. When the universe began 13.8 billion years ago in the Big Bang, it contained only the lightest elements: hydrogen, helium, and trace amounts of lithium. These primordial elements were created in the first few minutes after the Big Bang, as the incredibly hot, dense early universe cooled enough for protons and neutrons to stick together into simple atomic nuclei. But these three elements alone couldn't create planets, life, or you. For that, the universe needed heavier elements: carbon, oxygen, nitrogen, iron, calcium, phosphorus, and all the others that make up rocky planets and living things. And there's only one place in the universe where these heavier elements are created: inside stars. Stars are cosmic alchemists, fusion reactors that spend their lives transforming lighter elements into heavier ones. In the cores of stars, where temperatures reach millions of degrees and pressures are immense beyond imagination, hydrogen atoms are crushed together with such force that they fuse into helium. This process, called hydrogen fusion, is what makes stars shine. It's what has kept our sun burning steadily for 4.6 billion years, and it's what will keep it burning for another 5 billion years. But hydrogen fusion is just the beginning. As a star ages and exhausts the hydrogen in its core, the core contracts and heats up, eventually reaching temperatures high enough to fuse helium into carbon. This happens through a beautiful process called the triple alpha process, where 3 helium nuclei combine to form a single carbon nucleus. This carbon is the foundation of all organic chemistry, the basis of life itself. Every carbon atom in your body, in the trees outside your window, in every living thing on Earth, was created through this process in the heart of a long-dead star. But stars don't stop at carbon. Under the right conditions, with enough temperature and pressure, stars can fuse carbon into oxygen, oxygen into neon, neon into magnesium, and so on, building heavier and heavier elements. The oxygen you're breathing right now was created this way. The calcium in your bones, the iron in your blood, the phosphorus in your DNA, All of these were forged in the cores of ancient stars through nucleosynthesis. There's something incredibly peaceful about this process when you think about it. Stars take the simplest, most abundant element in the universe, hydrogen, and through the patient application of heat and pressure over millions or billions of years, they transform it into the rich diversity of elements we see around us. This isn't violent or chaotic. It's methodical, orderly, governed by the simple, beautiful laws of physics that apply everywhere in the universe. When a star massive enough to fuse elements all the way up to iron finally exhausts its fuel, its core can no longer support itself against gravity. The core collapses in less than a second, and the resulting rebound creates a supernova, an explosion so powerful it briefly outshines an entire galaxy. In this moment of cosmic drama, elements heavier than iron are created, things like gold, silver, platinum, uranium. The shock wave from the supernova scatters all these elements into space, seeding the interstellar medium with the raw materials for new generations of stars and planets. Our solar system formed 4.6 billion years ago from a cloud of gas and dust that had been enriched by the deaths of previous generations of stars. Everything in our solar system, from the sun to all the planets to every atom in your body, was recycled from the remains of earlier stars. You are not separate from the cosmos. You are made of it. Your atoms have journeyed through space and time for billions of years before temporarily coming together in the form of you. Think about this. The carbon in your muscles was created in a dying star perhaps 7 or 8 billion years ago. It was ejected into space in a supernova explosion, drifted through the interstellar medium for billions of years, eventually became incorporated into the molecular cloud that formed our solar system, condensed into the protoplanetary disk, was gathered into the early Earth, cycled through various rocks and minerals, perhaps spent time in the oceans, was incorporated into living things, moved through various organisms over billions of years, and finally ended up as part of you. Each of your atoms has a history older than our entire solar system. They've been to places you can't imagine, have been parts of countless different structures and entities before becoming part of you. And after your life ends, those atoms will continue their journey, eventually being scattered back into the environment, perhaps becoming part of other living things, and eventually, in the distant future when our sun dies, being ejected back into space to potentially become part of new stars and planets in some unimaginably distant future. This deep connection to the cosmos is not abstract or metaphorical. It's literal. You are made of star stuff. The universe is not something outside of you that you observe from a distance. You are a way the universe has of knowing itself, of experiencing itself from the inside. When you look up at the stars, you are starlight contemplating starlight, the universe gazing back at itself. There's something profoundly comforting about this realization. You are not separate from nature, not an intruder in the universe, not an alien presence in an indifferent cosmos. You are the universe in a temporary, localized, conscious form. The atoms that make you up have been part of the cosmos for billions of years and will continue to be part of it for billions more. You are as natural and as integral to the universe as stars, galaxies, and planets. You belong here completely. Moreover, this recycling of matter through the universe means that nothing is ever truly lost. The atoms that make up a dead star don't disappear. They're scattered into space, cooled and diffused, but they persist, ready to be incorporated into new structures. When our sun dies billions of years from now, The atoms that currently make up Earth and everything on it will be released back into space. Given enough time, they might become part of new solar systems, new planets, maybe even new forms of life we can't imagine. The universe wastes nothing. Everything is reused, recycled, transformed, but never destroyed. Energy changes form but never disappears. Matter rearranges itself but persists eternally. This cosmic recycling program has been operating for 13.8 billion years and will continue for as long as the universe exists. Nothing is thrown away. Nothing is lost. Everything returns in some form, somewhere, sometime. So as you rest here tonight, feel your connection to the stars. Feel the ancient heritage of your atoms, forged in stellar furnaces billions of years ago. You are not just in the universe. You are of it, made from it, an intimate and inseparable part of the cosmic whole. This connection is eternal. Your atoms have always existed and always will exist, flowing through the universe, taking different forms, but never truly vanishing. Let this knowledge comfort you. You are made of the same substance as stars, formed by the same processes that created everything beautiful in the universe. You are stardust that learned to think, cosmic material that became conscious. And when you feel small or insignificant, remember that you contain within you the creative history of the universe itself, billions of years of nuclear fusion and chemical evolution that culminated in the miraculous complexity of a living, thinking, feeling being. You are the universe's gift to itself, a way for cosmic matter to experience wonder and beauty and joy. Rest easy in this knowledge. You are exactly where you're supposed to be, made of exactly what you're supposed to be made of, a perfect and natural expression of the universe's fundamental creativity. The same force that creates stars and galaxies created you. You are part of the cosmic family, connected to everything that exists through the shared origin of your atoms. This connection cannot be broken. It's woven into the very fabric of your being. Cosmic harmony, orbital mechanics, and celestial rhythms. One of the most soothing aspects of our universe is its predictability. Despite the vast scales and immense energies involved, celestial bodies move in orderly, calculable patterns that have remained stable for billions of years. This cosmic choreography follows simple, elegant laws discovered by scientists like Johannes Kepler and Isaac Newton, laws that demonstrate the fundamental harmony underlying the apparent chaos of the universe. Every planet in our solar system follows an elliptical orbit around the Sun, a path that can be calculated with extraordinary precision. These aren't random wanderings through space. They're smooth, predictable curves through the void, repeated again and again with metronomic regularity. Earth completes its orbit every 365.25 days, the same period it's maintained for billions of years. Mars takes 687 Earth days to complete its orbit, Jupiter 11.86 Earth years, Saturn 29.5 years. These periods never vary. They're as reliable as clockwork because they're governed by the simple mathematics of gravity and motion. Kepler discovered 3 laws that describe planetary motion with beautiful simplicity. The first law states that planets move in elliptical orbits with the Sun at one focus. The second law, perhaps even more elegant, states that a line connecting a planet to the Sun sweeps out equal areas in equal times. This means that when a planet is closer to the Sun, it moves faster, and when it's farther away, it moves slower, but always in such a way that the mathematical relationship remains constant. The third law relates orbital period to orbital size, showing that the square of a planet's orbital period is proportional to the cube of its average distance from the Sun. These aren't just interesting mathematical relationships. They represent something profound. The universe operates according to rules that can be understood, patterns that repeat reliably. There's a deep order to celestial mechanics that has persisted since the formation of the solar system 4.6 billion years ago and will continue for billions of years into the future. Consider the Moon orbiting Earth. It makes this journey every 27.32 days, the same period it's maintained throughout human history and long before humans existed. Ancient peoples watched the same phases of the Moon we see today, following the same schedule, appearing in the same part of the sky at the same times. Billions of years ago, shortly after the Moon formed, it orbited Earth much closer and faster, but even then, it followed the same fundamental laws it follows today. The Moon's orbit is gradually changing, slowly spiraling away from Earth at about 3.8 centimeters per year due to tidal interactions. But this change is so gradual, so gentle, that it's imperceptible on human timescales. The Moon will continue to orbit Earth for billions of years, its motion as reliable and predictably as anything in nature. This is the pace of cosmic change. Slow, steady, following mathematical laws that never vary. Our solar system has maintained remarkable stability for billions of years. The same 8 major planets, plus dwarf planets like Pluto, have been orbiting the Sun in essentially the same configuration since shortly after the solar system formed. Jupiter has been in roughly the same orbit for 4.6 billion years. Saturn's magnificent rings, though they may be younger, have been present for at least hundreds of millions of years. The asteroid belt between Mars and Jupiter has contained countless small bodies in stable orbits for billions of years. This stability isn't an accident. It's a consequence of the way gravity works, creating natural balances and resonances that resist disruption. When objects settle into stable orbits, they tend to stay there unless something very unusual happens. And in the vast emptiness of space, unusual disruptions are rare. Planets don't randomly change their orbits. They follow paths that can be calculated millennia in advance with extraordinary accuracy. This predictability extends to eclipses, those dramatic celestial events when the Moon passes in front of the Sun or Earth's shadow falls on the Moon. Astronomers can calculate the exact timing and location of eclipses thousands of years into the past or future. Every eclipse follows from the orbital mechanics of the Earth-Moon system combined with Earth's orbit around the Sun. Ancient astronomers could predict eclipses because they recognized these patterns. Modern astronomers can do it with far greater precision, but the underlying predictability has always been there, waiting to be discovered. Even phenomena that seem irregular often contain hidden regularities. Comets appear to streak randomly through the inner solar system, but in fact, each one follows a precisely calculable elliptical or hyperbolic orbit. Halley's Comet returns to the inner solar system every 75 to 76 years, following the same path it's traveled for thousands of years. Ancient records describe its appearances going back more than 2,000 years, and each of these appearances happened right when orbital mechanics predicts it should have. The tides that rise and fall on Earth's shores follow the gravitational pull of the Moon and Sun, combining in patterns that repeat predictably. High tides occur roughly every 12 hours and 25 minutes, following the Moon's motion across the sky. Spring tides, when tides are especially high, occur when the sun and moon align during new and full moons. Neap tides, when tidal ranges are smaller, occur during quarter moons when the sun and moon pull at right angles. These patterns never change. They've been operating since the moon formed, and they'll continue operating for billions of years into the future. There's something deeply comforting about this celestial predictability. In a world where so much feels uncertain and chaotic, where human affairs seem impossibly complex and unpredictable, the heavens maintain their steady, reliable rhythms. The sun rises and sets. The moon waxes and wanes. The planets move through the zodiac on their appointed rounds. Seasons follow one another in orderly succession, driven by Earth's tilted axis and its orbit around the sun, a cycle that has repeated for billions of years and will repeat for billions more. This cosmic order isn't forced or artificial. It emerges naturally from the laws of physics, particularly gravity and inertia. An object in motion tends to stay in motion unless acted upon by a force. An object orbiting another object will continue that orbit indefinitely if nothing disturbs it. Gravity provides the force that curves the motion into an orbit, while inertia keeps the object moving forward. The result is stable, predictable motion that can persist for geological timescales without any maintenance or adjustment. Even in binary star systems, where two stars orbit their common center of mass, the dance is orderly and predictable. The two stars may orbit each other every few days or every few years, depending on their separation, but that orbit remains constant, following Kepler's laws just as planets do. Some binary stars are so regular they're used as natural clocks, their eclipses marking time with extraordinary precision. This harmony extends to the largest scales. Galaxy clusters, those vast collections of hundreds or thousands of galaxies, have stable structures maintained by the gravitational interaction of their members. Galaxies orbit within these clusters in predictable ways, following paths determined by the cluster's total mass distribution. Even the cosmic web itself, that largest-scale structure of the universe where galaxy clusters are arranged along filaments with vast voids between them, represents a kind of order emerging from the initial conditions of the universe and the subsequent evolution driven by gravity. The mathematics that describe these motions are often surprisingly simple. Kepler's laws can be derived from Newton's law of universal gravitation using basic calculus. Einstein's general relativity, which provides an even more accurate description of gravity, is more complex mathematically, but it still produces definite, calculable predictions that can be tested and verified. The universe isn't mysterious in the sense of being fundamentally unpredictable. It's mysterious in the sense of being far larger and more complex than we can fully grasp, but the underlying patterns are discoverable and describable. As you lie here tonight, you're on a planet spinning at about 1,670 kilometers per hour at the equator, completing one rotation every 24 hours. This planet is simultaneously orbiting the Sun at about 107,000 kilometers per hour, completing its orbit every year. The entire solar system is orbiting the center of the Milky Way galaxy at about 800,000 kilometers per hour. And the Milky Way itself is moving through space toward the Andromeda galaxy. Yet despite all this motion, you feel perfectly still, because everything around you is moving together in harmony. This is the gift of orbital mechanics. Stable, predictable motion that creates an environment where planets can exist, where life can arise and evolve, where you can lie quietly and contemplate the universe. The cosmic rhythms continue whether we notice them or not, maintaining the stable platform that makes our existence possible. The sun will rise tomorrow morning, following the same pattern it's followed for billions of years. The moon will follow its orbit, the planets will continue their stately procession through the zodiac, and the universe will maintain its ancient, reliable patterns. There's no need to worry about the cosmic machinery breaking down. It's been running smoothly for billions of years, and it will continue to do so for billions more. The laws of physics that govern these motions are among the most fundamental and unchanging aspects of reality. They operated the same way in the early universe, they operate the same way now, and they'll operate the same way in the far distant future. This is true stability, true reliability, on a scale that makes human concerns seem fleeting and temporary. Rest in this knowledge. The universe knows what it's doing. The celestial clockwork has been ticking reliably since long before you were born and will continue ticking long after you're gone. You are held within the stable cosmic framework, supported by billions of years of orderly motion. Everything is exactly where it should be, moving exactly as it should move, following the ancient, elegant patterns laid down at the universe's beginning. There's no chaos here, only harmony. No randomness, only law. No uncertainty, only the mathematical precision of celestial mechanics extending from the smallest satellite to the largest galaxy cluster. Let this cosmic order soothe your mind. The universe is fundamentally, deeply, reliably stable. The gentle giants, gas giants and their moons, in the outer reaches of our solar system, beyond the orbit of Mars and the asteroid belt, for enormous planets slowly trace their orbits around the sun. These are the gas giants: Jupiter, Saturn, Uranus, and Neptune. Despite their immense size and power, these planets exert a gentle, stabilizing influence on the solar system, and their serene beauty speaks to the calmer aspects of our cosmic neighborhood. Jupiter, the largest planet in our solar system, is so big that more than 1,300 Earths could fit inside it. Its mass is 2.5 times greater than all the other planets in the solar system combined. You might think such a massive object would be chaotic or violent, but Jupiter is actually a calming presence in our solar system. Its enormous gravitational field acts as something like a shepherd, helping to clear our region of space of potentially dangerous debris and helping to maintain the orderly structure of the entire planetary system. This giant planet has played a complex role in protecting inner planets like Earth. While recent research has shown that Jupiter's influence on comets and asteroids is more nuanced than previously thought, with studies showing it sometimes redirects objects toward the inner solar system rather than always deflecting them away, its overall gravitational influence has been crucial in shaping the architecture of our solar system. Jupiter's presence helped clear the primordial solar system of much of the debris left over from planet formation, contributing to the relatively stable environment we enjoy today. Saturn, perhaps the most visually stunning planet in our solar system with its magnificent ring system, orbits peacefully at about 9.5 times Earth's distance from the Sun. Working in concert with Jupiter, Saturn's gravitational influence helps maintain the stability of the outer solar system. Research has shown that both Jupiter and Saturn together are essential for effectively clearing small bodies from the solar system, preventing the inner planets from experiencing more frequent catastrophic impacts over cosmic time. Saturn's rings are a masterpiece of celestial beauty and gravitational physics. These rings, made primarily of water ice particles ranging from tiny grains to house-sized boulders, stretch out from the planet for hundreds of thousands of kilometers. Yet the entire ring system is remarkably thin, sometimes only 10 meters thick in places. Imagine a disk stretching the distance from Earth to Moon, but thinner than a 10-story building. The rings orbit Saturn with mathematical precision, their structure maintained by the gravitational influence of small moons called shepherd moons, which orbit alongside the rings and keep the particles confined to their elegant bands. The formation and longevity of Saturn's rings remains an area of active research, with some recent studies suggesting they might be relatively young, perhaps only a few 100 million years old, while others indicate they could be as old as the solar system itself. Regardless of their age, they represent a stable structure that demonstrates how gravity can organize countless individual particles into beautiful, coherent patterns. Each particle in the rings follows its own orbit around Saturn, yet collectively they create this stunning visual display that has captivated observers since Galileo first noticed something strange about Saturn's shape in 1610. Beyond Saturn lie Uranus and Neptune, ice giants that orbit in the solar system's far reaches. Uranus, tipped on its side so that its axis of rotation lies almost in the plane of its orbit, takes 84 Earth years to complete one circuit of the Sun. Neptune, the most distant major planet, requires 165 Earth years for a single orbit. These planets are so far from us, so removed from the inner solar system's hustle, that they seem to exist in a realm of cosmic tranquility, barely lit by the distant Sun, their deep blue atmospheres swirling slowly in the cold darkness. What makes these gas giants particularly soothing to contemplate is their moon systems. Jupiter alone has 95 known moons as of current counts, with 4 large moons discovered by Galileo in 1610: Io, Europa, Ganymede, and Callisto. These 4 Galilean moons are worlds unto themselves, each with unique characteristics that make them fascinating subjects of study. Europa, perhaps the most intriguing, has a surface of water ice covering what scientists believe is a vast liquid ocean. This ocean, kept liquid by tidal heating from Jupiter's gravitational pull, might contain twice as much water as all of Earth's oceans combined. The thought that beneath Europa's icy shell, there might be a dark, peaceful ocean, protected from the radiation and cold of space, is both scientifically exciting and somehow comforting. Somewhere in our solar system, there might be quiet waters, sealed away from the universe, where conditions could potentially support life. Ganymede, the largest moon in the solar system, is bigger than the planet Mercury. It's the only moon known to have its own magnetic field, creating a miniature magnetosphere within Jupiter's much larger magnetic bubble. Callisto, ancient and heavily cratered, is one of the oldest surfaces in the solar system, bearing the scars of 4.5 billion years of impacts, yet remaining fundamentally unchanged over cosmic time. Saturn's moon system is equally remarkable. Titan, Saturn's largest moon and the second largest in the solar system, has a thick atmosphere, denser than Earth's, made primarily of nitrogen. Titan is the only moon in the solar system with a substantial atmosphere and the only place besides Earth where stable liquid exists on the surface, though Titan's liquids are methane and ethane rather than water. Titan has lakes, rivers, and seas of liquid hydrocarbons, a hydrological cycle involving methane rain and evaporation, weather patterns, and even seasons. It's a world completely unlike Earth, yet one that shows how complex geological and atmospheric processes can operate in profoundly different environments. Enceladus, a small icy moon of Saturn, has captivated scientists with its cryovolcanic activity. From fractures in the ice at Enceladus's south pole, geysers erupt, shooting water vapor and ice particles hundreds of kilometers into space. This material falls back to the surface or escapes to form one of Saturn's rings. The existence of these geysers strongly suggests that Enceladus, like Europa, harbors a liquid ocean beneath its icy crust. The energy for these eruptions comes from tidal heating caused by Saturn's gravity, the same mechanism that keeps Europa's ocean liquid. The gas giant's moons demonstrate something beautiful about the universe. Complexity and activity can exist in seemingly barren, remote places. These moons, orbiting in the cold outer solar system far from the sun's warmth, are not dead rocks but dynamic worlds with their own geology, their own processes, their own unique characteristics. They remind us that interesting things can happen anywhere in the universe, given the right conditions. The gravitational interactions between these planets and their moons create what scientists call orbital resonances, elegant mathematical relationships between orbital periods. For example, Jupiter's moons Io, Europa, and Ganymede are locked in a 1:2:4 resonance. For every orbit Ganymede makes, Europa makes 2, and Io makes 4. These aren't coincidences but stable configurations that emerged naturally from gravitational interactions and have persisted for billions of years. The universe loves these kinds of patterns, these mathematical harmonies that arise from simple physical laws. The gas giants themselves are surprisingly simple in composition. Jupiter and Saturn are primarily hydrogen and helium, the same elements that make up the Sun, just not massive enough to ignite fusion. In fact, Jupiter is sometimes called a failed star, though this description isn't quite accurate. Jupiter was never close to being massive enough to become a star. It would need to be about 80 times more massive, but it does emit more heat than it receives from the Sun, slowly contracting under its own gravity and releasing gravitational potential energy as heat, a process that has been ongoing since the planet formed. These giant planets rotate rapidly despite their size. Jupiter completes a rotation every 10 hours, Saturn every 10.5 hours. This rapid rotation creates powerful winds and dramatic weather systems. Jupiter's Great Red Spot, a storm larger than Earth that has been raging for at least several hundred years, it was first observed in the 1600s, is perhaps the most famous example of these atmospheric phenomena. Yet even this massive storm, with wind speeds exceeding 400 kilometers per hour, follows predictable patterns. It doesn't rage chaotically, but rather maintains its basic structure year after year, decade after decade, century after century. The atmospheres of these planets show beautiful banding patterns, zones and belts of different colors and wind speeds, created by the planet's rapid rotation and their internal heat. These bands remain remarkably stable over time, shifting slightly but maintaining their overall structure. Even the violent storms that occasionally erupt in these atmospheres follow patterns that scientists can study and sometimes predict. There's something peaceful about knowing these giant planets are out there, slowly orbiting the Sun, maintaining their ancient patterns, their moons following their complex orbital dances. They're so far away that even traveling at the speed of the fastest spacecraft humans have built, it takes years to reach them. Voyager 1, launched in 1977, took 2 years to reach Jupiter and 3.5 years to reach Saturn. New Horizons, one of the fastest spacecraft ever launched, took 9 years to reach Pluto in the outer solar system. This remoteness adds to their serene quality. The gas giants exist in a realm we can observe through telescopes and study with spacecraft, but which remains fundamentally distant from our daily experience. Their worlds will likely never walk on, since they don't have solid surfaces, just ever-denser layers of gas transitioning eventually to liquid and then to exotic forms of matter under extreme pressure. To descend into Jupiter would be to sink through clouds of ammonia, layers of liquid hydrogen, eventually reaching a core of exotic metallic hydrogen under pressures millions of times greater than Earth's atmosphere, all while being crushed and heated to temperatures higher than the surface of the Sun. Yet, from our distant perspective, through telescopes or in photographs from spacecraft, these planets are simply beautiful. Jupiter's swirling bands of color, Saturn's majestic rings, Uranus's pale blue-green disk, Neptune's deep azure hue with its white clouds streaking across it. All of these create images of serene, otherworldly beauty. The gas giants remind us that our solar system is far larger and more diverse than the small rocky planet we inhabit. They add mass and gravitational stability to the system. They provide natural laboratories where we can study atmospheric dynamics, magnetospheres, and moon systems completely different from anything in the inner solar system. They've been orbiting the Sun for 4.6 billion years, and they'll continue for billions more, patient giants maintaining their stately procession through the outer darkness, their many moons accompanying them in their age-old dance. As you rest tonight, imagine these distant giants slowly moving along their orbits, their moons wheeling around them, everything following the ancient patterns established when the solar system was young. This cosmic order, this patient movement through space, has continued throughout Earth's history, throughout the entire span of life on our planet, throughout human history and prehistory, and will continue far into the future. The gas giants are there now, as they have always been, as they will always be for timescales that dwarf human civilization. There's comfort in this permanence, this stability, this ongoing celestial rhythm that forms the backdrop to our small lives on our small planet. Light's journey, the soothing nature of starlight. Every photon of light that reaches your eye when you look at a star has traveled an immense distance across space to bring you that information. Understanding the journey of starlight, the patient, steady nature of light's propagation through the universe, offers some of the most contemplative insights into cosmic processes. Light travels at a constant speed through the vacuum of space, approximately 299,792 kilometers per second, a speed often rounded to 300,000 kilometers per second for simplicity. This is the fastest possible speed in the universe, a fundamental constant of nature that nothing with mass can ever reach or exceed. Yet, despite being the speed limit of the universe, light still takes time to traverse cosmic distances, and that time can be immense. The light from our sun takes about 8 minutes and 20 seconds to reach Earth. This means when you look at the sun, which you should never do directly, of course, you're seeing it as it was 8 minutes ago. If the sun were to suddenly vanish, we wouldn't know for 8 minutes. We'd continue to see it and feel its warmth until the last photons that left its surface before its disappearance completed their journey to us. This 8-minute delay is our light travel time to the sun, and it represents the closest stellar light source we have. The next nearest star, Proxima Centauri, is about 4.24 light-years away. The light you would see from Proxima Centauri left that star 4 years and 3 months ago. If you looked at Proxima Centauri tonight with a powerful enough telescope, you'd be seeing it as it was in the middle of 2021. You'd be looking directly into the past, observing photons that began their journey toward Earth when that star's surface emitted them years ago. This gets more dramatic the farther out you look. Sirius, the brightest star in our night sky, is about 8.6 light-years away. The photons from Sirius that enter your eye tonight left that star in early 2017. Vega, another bright star, is 25 light-years away. Its light left in the year 2000. Betelgeuse, the red supergiant star marking Orion's shoulder, is roughly 550 light-years away, meaning the light you see from it tonight began its journey in the late 1400s, around the time Columbus was sailing to the Americas. There's something wonderfully contemplative about this time delay. When you look at the night sky, you're not seeing the universe as it is now, but as it was at various points in the past. Every star you see is a different time capsule, showing you that star's appearance at the moment its light began the long journey to your eyes. The night sky is a museum of cosmic history, with each point of light representing a different moment in the past. For nearby stars, this time delay is measured in years or decades. But as you look to more distant objects, the delays become far more significant. The Andromeda Galaxy, visible to the naked eye from a dark location as a faint smudge, is about 2.5 million light-years away. The light you see from Andromeda left that galaxy 2.5 million years ago, when early human ancestors were just beginning to use stone tools on Earth. Andromeda has completed about 10 orbits around its galactic center since that light began its journey to us. The photons that allow us to see these distant objects have been traveling through space for millions of years, crossing the vast emptiness between galaxies without stopping, without slowing, maintaining their course with perfect fidelity. Each photon is utterly simple, just a quantum of electromagnetic energy. Yet collectively these photons carry information across the cosmos, connecting us to objects so distant we can barely comprehend the scale. Light's journey is remarkably peaceful when you think about it. Photons don't struggle or strain to cross these distances. They simply move instantly at their creation, achieving light speed and maintaining it effortlessly until they encounter something. They pass through the vacuum of space without impediment, unaffected by the emptiness around them. Unlike spacecraft, which must carry fuel and thrust continuously or rely on gravity assists, light just goes, needing no propulsion, no energy input, just traveling at its constant, universal speed. This constancy of light speed is one of the universe's most fundamental properties. No matter how you're moving relative to a source of light, you'll always measure light coming from that source at the same speed. This fact, discovered and formalized by Einstein in his special theory of relativity, has profound implications for how space and time work, but at its core, it speaks to a deep regularity in nature. Light doesn't speed up or slow down based on circumstances. It simply travels at its natural speed, unchanging and unchangeable. The photons reaching us from distant objects are ancient. The farther away an object is, the older the photons we receive from it. The most distant objects we can see with our most powerful telescopes are so far away that their light has been traveling for over 13 billion years, almost since the beginning of the universe itself. These photons have spent the vast majority of cosmic history simply moving through space, crossing a distance so enormous that the universe itself has notably expanded during their journey. There's something almost meditative about imagining a photon's journey. Consider a photon created in a star hundreds of light years away. It begins its existence in the hot, dense interior of the star through a fusion reaction or as a result of energy cascading from the core. It then begins a random walk through the star's interior, being absorbed and re-emitted countless times by the dense plasma. This journey out of the star's interior can take thousands of years, the photon zigzagging chaotically through the stellar material. Finally, the photon reaches the star's surface and escapes into space. At this moment, its random walk ends, and it begins traveling in a straight line at light speed. For hundreds of years, it crosses the interstellar void. It passes through the thin gas between stars, encounters perhaps a few dozen atoms during its entire journey, but mostly travels through emptiness. It's unaffected by this emptiness, neither slowing nor deviating from its path. Eventually, after centuries of travel, the photon happens to intersect a small blue-green planet orbiting a yellow star. It enters the planet's atmosphere, still traveling at light speed. In a fraction of a second, it passes through the atmosphere, perhaps being scattered by air molecules along the way. Then it strikes a cornea, passes through the lens of an eye, and is absorbed by a molecule in a retinal cell, triggering a cascade of chemical reactions that result in an electrical signal traveling to a brain, where it's interpreted as a point of light in a constellation. The photon's journey is over, ended after centuries of travel, its energy finally absorbed and converted to a neural signal. But what a journey it was! Born in a fusion reaction in a stellar core, struggling through thousands of years of random diffusion to reach the star's surface, then centuries of unimpeded travel through the void, and finally a brief passage through an atmosphere before being detected by a living eye. Every time you look at stars, you're ending the journeys of countless photons that have traveled for years or centuries to reach you. You're participating in a process that connects you directly to distant suns, receiving messages from the universe sent long before you were born. This constant rain of photons from space has been falling on Earth throughout its history, carrying information about the cosmos to any organism capable of detecting it. The steadiness of this process is remarkable. Stars shine continuously, pouring out photons in all directions. These photons stream outward at light speed, forming an ever-expanding sphere of light around the star. Some tiny fraction of these photons happen to intersect Earth, but the vast majority fly off into space in other directions, potentially traveling forever through the cosmic void if they never encounter anything to absorb them. The universe is filled with these traveling photons, light from stars and galaxies flying through space in all directions, creating a complex overlapping web of electromagnetic radiation. The cosmic microwave background radiation, that faint glow from the early universe, consists of photons that have been traveling for 13.8 billion years, gradually redshifted by cosmic expansion from visible light to microwaves. These are the oldest photons we can detect, cosmic messages from the universe's infancy, still patiently traveling through space, still carrying information about the conditions that existed when they were created just 400,000 years after the Big Bang. Light doesn't age or decay during its journey. A photon created 1 billion years ago has exactly the same properties as a photon created a second ago, assuming they have the same energy. Time doesn't pass for a photon, in fact. Due to time dilation effects from special relativity, From the photon's perspective, its journey is instantaneous. It's created and absorbed in the same moment from its point of view. All the time we measure for light's journey exists only from our external perspective. The photon itself experiences no duration. This timeless quality of light adds another layer to its contemplative nature. Light exists in a kind of eternal now, always present, never experiencing before or after. The ancient photons from distant galaxies are, from their own perspective, no older than photons created a moment ago. They all inhabit the same timeless instant from their own frame of reference. As you lie here tonight, photons are falling on you from innumerable sources. The room's lights, if they're on, are showering you with photons created milliseconds ago in filaments or LEDs. If there's a window, photons from the moon reflected sunlight. And stars are entering photons that have traveled for seconds or years to reach you. Even in complete darkness, thermal photons, infrared light, are being emitted by everything around you, including your own body, filling the space with gentle electromagnetic radiation. You exist within this ocean of light, this constant flow of photons moving through space in all directions. The steadiness of this flow, the reliability of light's propagation, the patient journey of photons across cosmic distances, all of this speaks to a fundamental order in the universe. Light doesn't waver or doubt. It simply moves, carrying energy and information, connecting distant parts of the cosmos, allowing the universe to be known and observed and appreciated. Let yourself relax into this knowledge. Right now, photons from distant stars are completing journeys that began before you were born, just as new photons are beginning journeys that won't end for decades or centuries or millennia. This endless stream of light flowing through the universe is one of the cosmos's most constant features. A river of photons connecting everything that emits or reflects light, creating a web of electromagnetic communication that spans the observable universe. Rest in the knowledge that light is patient, constant, and universal. Every photon follows the same rules, maintains the same speed, travels predictably and reliably through space. The light reaching us from the most distant galaxies has crossed billions of light years to deliver its message, and it did so with perfect fidelity, maintaining the information it carried throughout that immense journey. This reliability, this constancy, is another reason we can trust the universe's fundamental orderliness. Light has been doing its job for billions of years and will continue for billions more, steadily carrying information through space, connecting all parts of the cosmos in an endless exchange of electromagnetic radiation. Dark matter and dark energy, the universe's gentle embrace. Perhaps nothing in modern cosmology sounds more mysterious or unsettling than dark matter and dark energy. These terms seem to evoke images of dangerous cosmic forces, but the reality is quite different and surprisingly comforting. Dark matter and dark energy are gentle, stabilizing influences that shape the universe at the largest scales, creating the structure and destiny of the cosmos in ways that are profound but non-threatening. Let's start with dark matter, which makes up about 27% of the universe's total mass energy content. We call it dark because it doesn't emit, absorb, or reflect light or any other electromagnetic radiation that we can detect. It's invisible to all our telescopes, no matter what wavelength they observe. Yet we know dark matter exists because we can observe its gravitational effects on visible matter and light. dark matter reveals itself in the rotation of galaxies. When astronomers measure how fast stars orbit around galactic centers at various distances, they find that stars far from the center are moving much faster than they should be based on the visible mass of the galaxy. There's not enough ordinary matter, not enough stars and gas clouds, to produce the gravitational pull necessary to hold these fast-moving outer stars in their orbits. The galaxies should fly apart, but they don't. Something invisible is holding them together, providing the extra gravitational pull needed to keep the galaxies intact. That something is dark matter. Dark matter forms enormous halos around galaxies, extending far beyond the visible disk of stars. These halos provide the gravitational scaffolding on which galaxies are built. Without dark matter, galaxies wouldn't have enough mass to form properly in the early universe, and they certainly couldn't maintain their current structures. Dark matter is essentially the skeleton of the cosmic architecture, the invisible framework that allows the bright matter we see to organize itself into galaxies, galaxy clusters, and the vast cosmic web. What's particularly peaceful about dark matter is how gentle and predictable its influence is. Dark matter only interacts through gravity, which is the weakest of the four fundamental forces in nature. It doesn't collide with ordinary matter, doesn't absorb or emit radiation, doesn't participate in any of the complex interactions that govern ordinary matter. It simply exists, providing gravitational pull, stabilizing structures, and going about its cosmic business without any drama or violence. Dark matter particles, whatever they turn out to be, scientists are still working on identifying them conclusively, pass through ordinary matter without interaction. Right now, as you lie here, countless dark matter particles are passing through your body, through the earth, through everything, completely unhindered and undetectable. They exert no force on you except gravity, and since the local concentration of dark matter is low and spread out, this gravitational effect is utterly negligible. Dark matter is everywhere but doesn't interfere with anything on human scales. This non-interacting nature means dark matter can't hurt us. It can't become toxic, can't cause mutations, can't damage cells or tissues. It's completely benign from a biological perspective. The dark matter halo surrounding our galaxy has been present for billions of years, was here when Earth formed, was here during the entire history of life on our planet, and has had no negative effect whatsoever on biological processes. It's simply part of the cosmic environment, as fundamental and as non-threatening as the geometry of spacetime itself. Dark matter played a crucial role in the formation of galaxies. In the early universe, shortly after the Big Bang, matter was distributed almost uniformly throughout space, with only tiny variations in density. These tiny variations began to grow through gravitational attraction. Denser regions pulled in more matter, becoming denser still, eventually collapsing to form galaxies. But this process wouldn't work fast enough with ordinary matter alone. Ordinary matter can lose energy through radiation, but dark matter can't, which actually helped it clump together faster in the early universe. Dark matter formed the first structures, creating gravitational wells into which ordinary matter could fall and eventually form stars and galaxies. The distribution of dark matter in the universe today reveals a beautiful cosmic web structure. Dark matter is concentrated along filaments connecting galaxy clusters, with vast voids in between. This web-like structure emerged naturally from the initial conditions of the universe and the way gravity caused structure to form over billions of years. Galaxy clusters sit at the intersections of these filaments, the nodes of the cosmic web, held in place by the gravitational influence of dark matter. Now let's consider dark energy, which is even more abundant than dark matter, making up about 68% of the universe's total mass energy content. If dark matter is mysterious because we can't detect it directly, dark energy is mysterious because we don't really understand what it is, even though we can measure its effects quite precisely. Dark energy was discovered in the late 1990s when astronomers were studying distant supernovae to measure the expansion rate of the universe. They expected to find that the expansion was slowing down due to the gravitational attraction of all the matter in the universe pulling everything back together. Instead, they found the opposite. The expansion is accelerating. Something is pushing the universe apart, counteracting gravity and causing space itself to expand faster and faster over time. This something is what we call dark energy. The name is somewhat misleading because dark energy isn't really a form of energy in the conventional sense. It's more like a property of space itself. The best current explanation is that dark energy is the vacuum energy, the energy inherent in empty space. According to quantum field theory, even completely empty space isn't really empty but is filled with quantum fluctuations, virtual particles constantly popping into and out of existence. These fluctuations have energy, and this energy could be what we observe as dark energy. The remarkable thing about dark energy is how incredibly weak and gentle its effect is on small scales. Dark energy only becomes significant over cosmic distances involving billions of light years. Within galaxies, within galaxy clusters, even over the scale of nearby galaxy groups, dark energy's effect is negligible compared to gravity. It's only when you look at the largest scales that dark energy's influence becomes dominant, gently pushing galaxy clusters apart, causing the expansion of space to accelerate. This acceleration is incredibly slow by human standards. The expansion of the universe isn't something you could ever directly observe or feel. The space between galaxy clusters is expanding, but this doesn't affect the size of galaxies themselves or solar systems or planets or atoms or you. All of these are held together by forces much stronger than the gentle push of dark energy. Only unbound structures, things not held together by gravity or other forces, experience this expansion, and even then, only over billions of years do the effects become noticeable. Imagine dark energy as the most gentle push imaginable, so weak that it only matters over distances of hundreds of millions or billions of light years, so subtle that it took sophisticated astronomical observations to even detect it. Yet despite this gentleness, over the vast scales and timescales of the universe, dark energy shapes cosmic destiny. It determines whether the universe will expand forever or eventually recollapse, and current observations strongly suggest the former. The universe will continue expanding eternally, gradually becoming colder and more diffuse as dark energy pushes everything apart. This might sound sad, but there's actually something peaceful about it. The universe won't end in a violent big crunch, with everything collapsing back together, temperatures rising, and all structures being destroyed in a reverse of the Big Bang. Instead, the universe will simply expand forever, gradually cooling, stars eventually burning out, galaxies slowly dispersing, everything fading into a cold, dark, but peaceful final state over timescales so vast they make current cosmic history seem like an instant. Both dark matter and dark energy remind us that the universe is far stranger and more subtle than our everyday experience suggests. Most of the universe's content isn't the ordinary matter we're made of, the atoms that form stars and planets and people. The universe is dominated by these mysterious components that reveal themselves only through their gravitational effects and their influence on cosmic structure and evolution. Yet these invisible components aren't threatening. They're not dangerous dark forces waiting to harm us. They're simply part of how the universe works, as fundamental to cosmic structure as gravity and electromagnetism. Dark matter provides the scaffolding for galaxy formation and holds galaxies together. Dark energy determines the ultimate fate of cosmic expansion. Both are essential parts of the cosmic machinery, working on scales so vast that they're essentially invisible in our daily lives, yet fundamental to the largest scale structure and evolution of everything that exists. The universe is mostly invisible, mostly made of things we don't fully understand, and that's okay. This mystery doesn't make the universe less trustworthy or more dangerous. The same laws of physics apply everywhere. The same cosmic processes that have been operating for billions of years continue today. Dark matter and dark energy have been around since the early universe, have been shaping cosmic structure throughout cosmic history, and have done so in completely predictable ways that follow mathematical laws we can describe even if we don't fully understand the underlying nature of these phenomena. As you rest here tonight, you're surrounded by dark matter, held within its invisible web, part of a galaxy structured and stabilized by its presence. You're living in a universe where dark energy gently pushes the largest structures apart, determining cosmic destiny over timescales so vast they become abstract. And none of this affects your immediate experience because these forces operate so gently and on such vast scales that they're completely irrelevant to daily life. The universe is gentle in its most fundamental structures. The invisible components that make up most of its mass and energy are non-threatening, operating according to rules, providing stability and structure, doing their jobs quietly and reliably. There's comfort in knowing that even the universe's mysteries are gentle ones, that the unknown parts of reality aren't dangerous but simply parts of a larger cosmic order we're still working to fully understand. Cosmic phenomena, beautiful and distant. The universe contains phenomena of breathtaking beauty and mind-boggling power, but what makes them soothing rather than frightening is their distance and the timescales on which they operate. Stellar nurseries, black holes, pulsars, and supernovae are all spectacular cosmic events, but they're so far away and so rare that they pose no threat while offering endless wonder. Nebulae, those vast clouds of gas and dust scattered throughout galaxies, are among the most beautiful objects in the universe. When we see images of nebulae from telescopes like Hubble, we're seeing stellar nurseries, places where new stars are being born from the gradual collapse of interstellar material. The process of star formation takes millions of years, unfolding with the patience characteristic of all cosmic processes. Consider the Orion Nebula, one of the closest star-forming regions to Earth at about 1,340 light-years away. This glowing cloud of gas, visible to the naked eye as the middle star in Orion's sword, is roughly 24 light-years across, contains enough material to make thousands of stars, and is actively forming new stars right now. The process is gentle and gradual. Dense clumps of gas slowly collapse under their own gravity, taking hundreds of thousands of years to condense into protostars. These protostars eventually become hot enough to ignite fusion and become true stars, but even this ignition is a gradual process, not a sudden explosion. The Eagle Nebula, made famous by Hubble's Pillars of Creation image, shows this process in stunning detail. Those towering pillars of gas and dust, each several light-years tall, are being slowly eroded by radiation from nearby young stars while simultaneously giving birth to new stars within their dense cores. The interplay of creation and destruction happens so slowly that even if we could watch the nebula continuously for a human lifetime, we'd see no visible change. These structures evolve over tens of thousands of years, imperceptibly slow by human standards, but inexorably following the physical laws that govern gas dynamics and star formation. Black holes, despite their fearsome reputation, are actually quite benign from a distance, which is where all black holes are from our perspective. A black hole is a region of space where gravity is so strong that not even light can escape from within a boundary called the event horizon. They form when massive stars collapse at the end of their lives, or sometimes through the merger of smaller black holes or through direct collapse of gas in the early universe. The nearest known black hole to Earth is about 1,560 light-years away, too far to have any effect on us whatsoever. Black holes don't reach out and grab things. Their gravity outside the event horizon is exactly the same as the gravity of the star that collapsed to form them. If our sun were somehow replaced by a black hole of the same mass, which is impossible since the sun isn't massive enough to form a black hole, Earth's orbit wouldn't change at all. We'd notice the sudden darkness and cold, obviously, but gravitationally, nothing would be different. Black holes are remarkably simple objects, described completely by just three properties: mass, spin, and electric charge. Everything else about the matter that fell into them is lost, hidden behind the event horizon in a way that makes black holes among the most perfect objects in the universe. They're like cosmic vacuum cleaners, sitting in space, capturing any matter or light that comes too close, but otherwise just being gravitational objects like any other massive body. Supermassive black holes sit at the centers of most large galaxies, including our Milky Way. The Milky Way's central black hole, called Sagittarius A star, has a mass about 4 million times that of our Sun, yet it's so far away, about 26,000 light-years, that it has no direct effect on us here in the outer regions of the galaxy. It sits at the galactic center, with stars orbiting around it in a complex dance, some of them whipping around the black hole at tremendous speeds but still obeying the same laws of orbital mechanics that govern planets around stars. Recent observations have even captured an image of the environment around a supermassive black hole in the galaxy M87, showing the shadow of the event horizon surrounded by glowing hot gas. This image, created by linking radio telescopes around the world into a planet-sized virtual telescope, shows the black hole as a dark circle surrounded by a bright ring, exactly as Einstein's general relativity predicts. Black holes, despite their mystery, obey the laws of physics precisely, behaving exactly as our theories say they should. Pulsars are another cosmic phenomenon that sounds exotic, but is actually quite peaceful from our perspective. A pulsar is a rapidly rotating neutron star, the ultradense remnant of a supernova explosion. As the pulsar rotates, beams of radiation from its magnetic poles sweep through space like a cosmic lighthouse. If one of these beams happens to sweep past Earth, we detect regular pulses of radiation, hence the name pulsar. Pulsars rotate incredibly fast, some completing hundreds of rotations per second, and they do so with extraordinary precision. The most stable pulsars, called millisecond pulsars, are so regular in their rotation that they rival atomic clocks in their timekeeping precision. These cosmic lighthouses have been flashing their beams into space for thousands or millions of years, maintaining their regular rhythm with remarkable constancy. The discovery of pulsars initially puzzled astronomers so much that the first pulsar signal was jokingly nicknamed LGM-1 for little green men, because the regular pulses seemed almost artificial. But of course, they're natural phenomena, examples of the extreme physics that can occur in nature under conditions we can barely imagine, but that follow the same fundamental laws that govern everything else in the universe. Supernovae, the explosive deaths of massive stars, are among the most energetic events in the universe. When a star more than about 8 times the Sun's mass exhausts its nuclear fuel, its core collapses in less than a second, and the resulting rebound blows the star apart in a catastrophic explosion. For a few weeks, a supernova can outshine an entire galaxy of hundreds of billions of stars. Yet supernovae are rare enough and distant enough that they pose no threat to us. A supernova would need to occur within about 30 light-years of Earth to significantly affect our planet's biosphere, and there are no stars that close to us that are massive enough to explode as supernovae. The most likely candidate for a nearby supernova is Betelgeuse, which is about 550 light-years away, safely distant enough that when it does explode, which could be any time in the next 100,000 years or so, it will be a spectacular show in the night sky but will pose no danger to Earth. Supernovae, despite their violence, serve a crucial creative role in the universe. They're the primary mechanism by which heavy elements, forged in stellar cores, are scattered back into the interstellar medium where they can be incorporated into new stars and planets. Every supernova enriches its neighborhood with carbon, oxygen, iron, and heavier elements, contributing to the gradual increase in heavy element abundance that has occurred throughout cosmic history. Without supernovae, there would be no rocky planets, no heavy elements to build complex chemistry, no elements heavier than iron. The remnants of supernovae are also beautiful and scientifically fascinating. The Crab Nebula, the remnant of a supernova observed by Chinese astronomers in the year 1054, is an expanding cloud of gas enriched with heavy elements, now about 11 light-years across and still expanding. At its center sits a pulsar, the dense core of the exploded star, rotating 30 times per second and powering the nebula's glow through its intense magnetic field and radiation. Gamma-ray bursts are perhaps the most energetic events in the universe, brief flashes of gamma radiation that can release more energy in a few seconds than the sun will emit in its entire 10 billion-year lifetime. They're caused by the formation of black holes, either in massive stellar collapses or in collisions between neutron stars. Fortunately, gamma-ray bursts are extremely rare and are beamed in narrow jets, so only observers along the beam direction see them. The chances of Earth being in the path of a gamma-ray burst from a nearby source are incredibly small, and even if it happened, the Earth's atmosphere would absorb most of the gamma rays, though there could be some effects on the atmosphere itself. But here's the comforting truth. All of these dramatic cosmic events are rare and distant. On average, a supernova occurs in our galaxy about once every 50 years, but the galaxy is so large that these explosions happen far from us. Gamma-ray bursts occur in the observable universe at a rate of about once per day, but spread across billions of galaxies, each one far away. Black holes exist throughout the universe but don't roam around threatening planets. They're bound by the same gravity that holds stars in their orbits, following predictable paths through space. The universe can be violent and energetic on appropriate scales, but it's also vast enough that these events are essentially always happening far away from us, and rare enough that any given region of space experiences them only occasionally over cosmic timescales. We live in a safe, quiet region of a stable galaxy, orbiting a well-behaved star, in an era when the universe has settled into a relatively mature state where the most dramatic events of the early universe are long past. Thinking about these phenomena, appreciating their beauty and power while understanding their distance and rarity, offers a unique kind of peace. The universe is capable of spectacular displays, tremendous releases of energy, transformations that reshape space on the largest scales. Yet none of this threatens our existence. We're spectators to cosmic processes, able to observe and study and appreciate them from the safety of our small blue planet, held in its stable orbit, protected by our sun's relatively quiet and predictable fusion. As you rest tonight, these processes continue in galaxies near and far. Stars are being born in nebulae. Black holes are slowly consuming nearby matter. Pulsars are spinning their regular rhythms. And somewhere in the universe, a massive star is ending its life in a supernova explosion. But all of this happens at distances measured in thousands or millions of light years, occurring on timescales so vast or so brief that they don't affect our daily experience. The universe's drama plays out on stages far from home, while here, in our cosmic neighborhood, everything proceeds peacefully, governed by the same reliable laws that have maintained stability for billions of years. The overview effect and cosmic perspective. There's a phenomenon astronauts report when they see Earth from space for the first time. It's called the overview effect, and it describes a cognitive shift in awareness that occurs when viewing our planet from orbit or beyond. This shift, understanding our place in the cosmic perspective, offers perhaps the most profound sense of peace that contemplating the universe can provide. From space, Earth appears as a small, fragile sphere suspended in the vast darkness, wrapped in its thin atmosphere, alone in the void. The borders and divisions that seem so important on the ground are invisible from space. The conflicts and concerns that dominate our daily lives appear tiny and temporary when viewed against the backdrop of cosmic time and space. Carl Sagan captured this perspective beautifully when discussing the pale blue dot image taken by Voyager 1 from beyond Neptune in 1990. From 6 billion kilometers away, Earth appears as a single pixel, a tiny point of light suspended in a sunbeam, barely distinguishable from the background of space. Sagan reflected on how this image should give us perspective on our importance, our conflicts, our sense of self-importance. Every human who has ever lived, every drama and comedy, every triumph and tragedy, all occurred on that tiny stage, that mote of dust suspended in a sunbeam. This perspective isn't meant to diminish human experience, but to contextualize it. Your life is meaningful and important. Your experiences matter. Your relationships are real and significant. But placing them in cosmic context can help ease the weight of worries and anxieties. The things you stress about today will be forgotten in a few years, will matter to no one a few decades from now, will be utterly erased from memory within a century or two at most. Not because they're unimportant now, but because that's the nature of human concerns, which exist in the moment and for those present in that moment. The universe operates on different scales entirely. Stars burn for billions of years. Galaxies evolve over tens of billions of years. The universe itself may exist eternally into the future, gradually expanding, cooling, but continuing indefinitely. Your life is a brief flicker in this vast expanse of time, but that briefness makes it precious, not meaningless. You exist now, in this moment, able to contemplate the cosmos that created you, and that's extraordinary. From a cosmic perspective, humanity itself is very young. Anatomically, modern humans have existed for about 300,000 years, which sounds like a long time until you realize that's only 0.0022% of Earth's 4.5 billion year history. Civilization, agriculture, writing, cities, all the complex structures we think of as defining human existence are only about 10,000 years old. The entire span of recorded human history would fit into the last few seconds if you compressed Earth's history into a single year. And Earth itself, despite being our home and the only place we know with life, is just one planet orbiting one star among hundreds of billions of stars in one galaxy among trillions of galaxies. This isn't to say Earth or humanity is insignificant, but rather to provide perspective. Our planet is special because it's ours, because it harbors life, because it's where our story takes place. But it's also an ordinary rocky planet orbiting an ordinary star in an ordinary spiral galaxy. This ordinariness is actually comforting. We're not uniquely positioned to be threatened by cosmic dangers. We're not in the center of the universe where all forces converge. We're in a quiet suburban region of our galaxy, orbiting a stable star, at a time in cosmic history when the universe has settled into a relatively mature state. We're cosmic small-town residents, living peaceful lives far from the active galactic centers and intense radiation environments that characterize more dramatic regions of space. The cosmic perspective also reveals how connected everything is. The oxygen you breathe was created in stars. The carbon in your body was forged in stellar cores. The heavier elements around you were created in supernova explosions. You're made of processed star material, assembled through billions of years of cosmic evolution. Every atom in your body has a history stretching back to the Big Bang, has been part of multiple stars, has existed in various forms throughout the history of the universe. Moreover, you're part of an unbroken chain of life that stretches back billions of years on Earth. Every one of your ancestors, going back through human evolution, through mammalian evolution, through vertebrate evolution, through the first multicellular organisms, through the first cells, every single one of them survived long enough to reproduce. You exist because of an unbroken chain of survival and reproduction spanning billions of years. You're the current culmination of life's entire history on this planet, carrying within you the heritage of every organism that came before. This perspective can help you appreciate the improbability and preciousness of your existence. The universe is mostly empty space. Most of space is at temperatures near absolute zero. Most places in the universe are hostile to life as we know it. Yet here, on this small planet, conditions are just right for liquid water, for complex chemistry, for life, for consciousness. You exist in one of the universe's rare oases of habitability, during one of the universe's rare periods of complex structure, after stars formed but before they all burn out, as one of the universe's rare conscious beings able to contemplate its own existence. When astronauts report the overview effect, they often describe a sense of peace and unity. Seeing Earth from space, national boundaries disappear. Political disputes seem petty. The atmosphere appears impossibly thin and fragile. The sense of all humanity being together on this small world, sharing a common home, becomes overwhelming. Problems that seemed insoluble from ground level appear manageable when viewed from the perspective of space. You don't need to go to space to benefit from this perspective. You can cultivate it through contemplation, through learning about astronomy and cosmology, through consciously thinking about your place in the universe. When daily concerns feel overwhelming, zooming out to cosmic perspective can help. Your deadline is stressful now, but meaningless on cosmic timescales. Your embarrassment feels acute, but no one will remember it in a few years. Your failures seem permanent, but everything is temporary against the backdrop of billions of years. This isn't nihilism. It's not saying nothing matters because we're small in a big universe. Rather, it's freeing you to decide what matters based on your values rather than feeling pressured by artificial urgency. The universe doesn't care about your meeting tomorrow or your social anxiety or your career trajectory. The sun will continue burning regardless. Galaxies will continue their stately orbits regardless. This cosmic indifference is actually liberating. It means you're free to care about what actually matters to you, free to define meaning and purpose for yourself, unburdened by cosmic judgment that doesn't exist. The cosmic perspective also reminds us that change is the only constant. Everything that exists will eventually change form. Mountains erode, oceans evaporate, continents drift, species evolve or go extinct. Stars are born and die, galaxies collide and merge. Even the universe itself evolves, expanding, cooling, transforming. Nothing is permanent except change itself and the physical laws that govern that change. Understanding this impermanence can actually be comforting. Your current problems are temporary because everything is temporary. Whatever difficulty you're facing will eventually pass, transformed by time into something else, eventually fading to irrelevance. Not because your problems don't matter, but because that's the nature of things in a universe characterized by constant change and evolution. Yet amid this change, there are constants. The speed of light never varies. The gravitational constant remains stable. The fundamental forces and particles that make up matter remain the same throughout cosmic history. The laws of physics that operated in the early universe still operate today. This combination of change and constancy, evolution within a framework of unchanging laws, creates a universe that's both dynamic and stable, both surprising and predictable. As you lie here tonight, thinking about cosmic perspective, recognize that you're part of something vast and ancient and ongoing. You're a temporary pattern of matter and energy, arranged in a configuration that has never existed before and will never exist again. You're unique in the history of the universe, yet made of the same stuff as stars and planets. You're insignificant on cosmic scales, yet precious beyond measure to those who know you. You're mortal and temporary, yet connected to something eternal through the atoms that compose you and the patterns of thought and feeling that characterize consciousness. The universe created you through billions of years of evolution. You are its way of knowing itself, of experiencing beauty and wonder, of contemplating its own existence. When you look up at the stars, the universe is observing itself. When you think about cosmic history, the universe is remembering itself. When you feel awe at the scale and beauty of existence, the universe is appreciating itself. This cosmic perspective offers a unique kind of peace. The peace of understanding your true place in the grand scheme of things, neither inflated to cosmic importance nor diminished to meaninglessness, but accurately perceived as a temporary, localized, conscious expression of the universe's matter and energy, valuable beyond measure to yourself and those around you, but temporary and small in the vast cosmic context. This understanding can free you from excessive worry, from false urgency, from the weight of concerns that feel crushing but are actually manageable when properly contextualized. Rest in this cosmic perspective. You are exactly where you're supposed to be, on a small planet orbiting a stable star, in a quiet region of a spiral galaxy, during an era when the universe has matured enough to support complex structures but hasn't yet run down toward its eventual heat death. You're living in one of the universe's good neighborhoods during one of its most interesting eras. You're safe, held within structures that have proven stable for billions of years, subject to laws that never vary, part of a universe that has shown itself to be fundamentally orderly and comprehensible. The cosmic perspective isn't cold or alienating. It's warm and inclusive. You belong here. You're made of this universe, created by it, part of it. You're not an observer looking at the universe from outside, but a way the universe experiences itself from within. When you feel connected to the cosmos, you're recognizing a literal truth. You are connected intimately and fundamentally, through every atom of your being, through the physical laws that govern your existence, through the evolutionary history that created consciousness from simple matter. Let this connection soothe you. Let the cosmic perspective ease your worries. Let the understanding of your place in the universe bring peace. You are held within something vast and ancient and reliable, something that has been unfolding for billions of years according to simple, elegant laws, something that will continue for billions more years regardless of your temporary concerns. Rest in that knowledge. Let it comfort you. Let it help you release the tensions and anxieties that feel so pressing but are actually so temporary. The universe is patient. The universe is vast. The universe is stable. And you are part of it, connected to everything through your shared atomic heritage, through the common origin of all matter in the Big Bang, through the unified laws of physics that govern everything from quarks to galaxy clusters. You are cosmically connected, universally part of the whole, temporarily manifested as an individual consciousness but fundamentally and eternally connected to everything that exists. Conclusion and call to action. As we come to the end of our gentle journey through the cosmos, I hope you've found some peace in these facts about the universe. We've traveled from the vast emptiness between stars to the patient timescales of cosmic evolution, from our stellar origins to the predictable rhythms of celestial mechanics. We've visited the gas giants and their moons, contemplated the patient journey of light across space, understood the gentle nature of dark matter and dark energy, and appreciated both the beauty of cosmic phenomena and the perspective that comes from understanding our place in the universe. The universe, when you really examine it, is not a hostile or threatening place. It's vast, yes, and indifferent to human concerns, but also stable, predictable, and governed by elegant laws that create order from apparent chaos. The cosmic processes that seem violent or dramatic, like supernovae or black holes, occur at such distances and on such scales that they pose no threat to us while offering endless opportunities for wonder and study. You are made of atoms forged in the hearts of ancient stars. You stand on a planet that has maintained habitable conditions for billions of years, orbiting a star that burns steadily and reliably, held within a galaxy structured by invisible dark matter, living in a universe that expands gently under the influence of dark energy, all of it following laws that never vary, patterns that persist, processes that continue with remarkable reliability. When you feel anxious or worried, remember the vast emptiness of space, how much room there is in the universe, how everything has space to exist without crowding or pressure. When you feel rushed or urgent, remember cosmic timescales, how billions of years pass in the life of a star, how patient the universe is with all its processes. When you feel disconnected or alone, remember that you're made of stardust, connected to everything in the universe through your shared atomic origins. The same forces that create and maintain stars and galaxies, that shape cosmic structure on the largest scales, that have operated since the beginning of time, these same forces operate in you. You are not separate from the cosmos but an integral part of it, a temporary but precious configuration of matter and energy, experiencing the universe from the inside. As you drift off to sleep tonight, imagine yourself floating peacefully in space, weightless and calm, surrounded by the gentle light of distant stars. Feel yourself part of something vast and ancient, held within patterns that have persisted for billions of years and will persist for billions more. Let the cosmic perspective ease your worries. Let the reliability of physical laws comfort you. Let the connection to the universe through your very atoms remind you that you belong here completely. The universe will be here tomorrow, vast and patient, ready to share more of its quiet secrets whenever you wish to listen. The stars will continue their steady burning, the galaxies their slow rotation, the cosmic expansion its gentle acceleration. Everything continues, reliable and ordered, following the patterns established at the beginning of time. Thank you for joining me on this journey through the cosmos. If you found this exploration peaceful and helpful, I'd be grateful if you'd like this video and subscribe to the channel for more relaxing deep dives into science and the universe. Your support helps me create more content like this, more opportunities to explore the gentle, soothing truths about our universe together. But for now, let yourself rest. Let yourself drift into sleep, held within the cosmic order, connected to everything, part of the vast, patient, beautiful universe that created you and sustains you. The universe is vast and you are small, but you are part of it, made of it, connected to it, held within it. Sleep well, cosmic traveler. The universe watches over you with its ancient, steady rhythms, its reliable laws, its patient processes. Everything is as it should be. Everything continues as it always has. You are safe. You are held. You are part of something vast and wonderful and eternal. Good night.